Welcome to the presentation and thanks for watching. We're going to be installing the Application Director appliance today. It's a fairly easy process. Download the appliance first to the local disk for quicker installation. Use fixed IP addresses and have an entry in the DNS. Accept the user license agreements. Name your appliance and click Next. Select your storage. Click Next. Leave the defaults. Select your port groups where the appliance is going to be connecting to. Fixed IP addresses are preferred. Enter the IP address. Make sure that you have a DNS entry in the DNS. Power on the appliance after you finish. This is where it will take quite a bit of time depending on where the appliance was downloaded to. Here we have speeded it to 200%. Now we'll power on the appliance and enter the license. So go into the console and power on the appliance. Enter the license keys. You can get that from our website or talk to your sales rep. Enter the login passwords for the root and the Darwin user. Rapid server comes up. Enter the password for the admin user. Please note that that was a root shell in which you entered the login password. Login as admin. First, we attach a cloud where Application Director will deploy. From the drop-down list, select Cloud Providers. Enter. Click New. Enter name and description. And select the provider type. Enter IP address of the cloud provider. Enter the organization, the admin login password of the admin. Validate the connection. Make sure that you see a green check. Next, we let Application Director know about the cloud provider templates that are available to use during deployment of blueprints. Click New. From the drop-down, select the catalog. Get the templates. Select the templates that are available to us. Click OK. Next, from the drop-down list, select Deployment Environment. Enter name and description. And then select the provider that we created earlier. Now select the organization virtual data center that the cloud provider has created for us to use. Select from the drop-down list, select OK, and then save. Tags helps us in filtering and categorizing the services. Let us create one for SpringTrader. Enter the tag name and the description. In the type, we will select the server type. We will show you later how we can filter when we are building up blueprints. Save it. Next on the list is operating systems. The template from the cloud provider catalog was a 64-bit CentOS 6.3 version. Let's make sure that we have defined it in Application Director. Next, we create logical mappings of vCloud Director catalog templates in Application Director. This allows loose coupling between templates in App Director and cloud providers. Cloud providers may independently change their templates, and Application Director just has to remap the logical relationship. Logical mappings help App Director to remain agnostic of cloud providers. Let's create a new logical template for SpringTrader application. Enter the name of the template and a description and save. Click on the new button. We enter the version number, enter a description. Here we tag, enter the description. Here we tag the templates that is going to be used for different services. And note, I'm also including a SpringTrader tag that we created earlier. Next, we select the supported operating system, in this case CentOS 6.3. Now we select a cloud provider to map, and then the template that was provided by the cloud provider. Next, we look at the services that we could include, but in this case we don't have any, so we won't. Hit the save button, and we have created a template, logical template. Next on the list is tasks. Tasks are used for additional customization during execution of blueprints. In my example, the customs task will accept the EULA when installing vFabric suite of products to eliminate user interaction. I have already created one here, VMware EULA. Let's take a look at that, version 101. You can see the properties that I've defined, the location of the EULA, and the repo that we need to install for the operating systems. They are all Red Hat based. And taking a closer look, you will see that we have defined those properties and they could be used during the deployment. And here's a script that accepts the EULA certificates and runs the RPMs. Next, we will see how to create services. Services are scripts that are run inside the deployed VM in the cloud. They may be used in automated software installation. The script writer has complete control over the install and configuration. In App Director, out of the box, there are many services defined. Let's take a look at vFabric RabbitMQ. Then I'll show you how I created a new Rabbit service for my version of SpringTrader application. There is the description field, which gives you a lot of information about what this service has to offer. It is tagged as other. The supported components are scripts, which means we can do additional customization of services. This particular service is scripted to run on these guest OS platforms only. Let's expand the properties and see in detail how they are created. Node IP is a string. The autobind is set to consume. This means that when we create blueprints and set up dependencies, this value of the field will be filled automatically during the execution of blueprint. Autobind requires tags to be set. In this example, it points to its own IP address. Similarly, node IP, Rabbit node IP is a computed string. It means that the value will be set and exposed to other services during installation. Script is run in the VM. Rabbit node port sets the default port on which the Rabbit service will listen. It is not overridable. The last two properties are content types. The application will download the content from itself to the VM. The first of the two is global conf. It's the shell script with various environment variables set. The second is RabbitMQ installation bits. The global conf has environment variables that can be customized as well, and they're downloaded during the installation of the software inside the VM. That is a link to download the tar bits for Rabbit from Application Director. Let's minimize this and go and see what the scripts are doing. Let's see how it comes together in the service scripts. There are lifecycle scripts which are run at various times during deployment. There are no hard and fast rules on how to use them. Our recommendation would be to split the script based on functionality. Here, all the scripting is done in install stage. See, the global conf is sourced, so the environment variables are available to all parts of the scripts. Proxies are set in case VMs are behind a firewall and they need to download additional software from the internet. These scripts are written for various Linux distributions. As you scroll down, you'll see some of the installation is hard-coded with version numbers. And they are for different types of Linux distros. For example, you have RPMs for Red Hat derived distros and apt-get for Ubuntu-based distros. The install script uses the Python script that was downloaded from the app director to install Rabbit. As you can see, the various version numbers of the software is being downloaded from the internet and then will be installed inside the VM during the deployment time. And you can see the Rabbit node IP is set at the bottom of the script, and that's a computed property. Let's take a look at the RabbitMQ that I created for the SpringTrader application. Let's create a new RabbitMQ service customized for SpringTrader application. Enter the name, description, and save. Key thing to note is that there is no right or wrong way to write the scripts. Only thing that matters is how one is able to maintain the scripts in the long run. I like to borrow the adage from object-oriented programming. Keep things that change rarely in the scripts, things that change often in properties. Click on the Create New Version. Enter the name, description. Tag it as shown. Select script for supported components. For this exercise, we just selected CentOS 6.3 64-bit version. You may add more operating systems later. Let's create some properties now. Since we are installing RPMs and not from source, we need to install EPEL repository. Then we tell the script which version of Rabbit to install from EPEL. EPEL is a repository source maintained by the community. Let's mark them required. This means that the value cannot be blank and overridable. This allows us to modify the values during blueprint execution. Create two additional properties for proxy server and proxy port if behind a firewall. These are marked not required, but we can override them at execution. The script will handle if they are defined or not. This is similar to the global conf we downloaded in our out-of-the-box RabbitMQ service. To modify the global conf file, you will need admin access to the appliance. This is an alternate method of defining properties. There are use cases where you might want properties to be available across the board, in which case global conf is a great way to provide that capability. Let's create the bash script. I copied and pasted the script. From the drop-down menu, you can see the properties that were created and used here. You can see how we set up the proxy variables. Install EPEL, Erlang, a prerequisite for Rabbit, and then finally Rabbit itself. Finally, we start the Rabbit service. Similarly, we create other services that make up the SpringTrader application. I will post a link at the end of the show to download the blueprints, and you can import them into your own application director appliance instance.
Let's build the SpringTrader application. It requires 5 nodes. These nodes make up the 3-tier SpringTrader application. Enter the name, description, and version and save. In the left column, in logical templates, enter SpringTrader to filter the list. Similarly, in the right column, under services, enter SpringTrader to filter the list. This is why it is a good practice to tag and name the templates and services appropriately. Even in a mid-size environment with various permutation and combinations, the list can get quite long. The first node that we are creating is a RabbitMQ node. Enter the name, host name as shown. Modify CPU and memory as needed. Work with the developers and IT staff to get this value. Click on the service and enter the property values as shown. The next 2 nodes we are going to create are the SQL file locators and SQL file servers. Drag and drop the nodes and rename the node and give it a host name. Enter vCPU and memory values. Increase the cluster size to 2. Similarly, drag and drop a next node, which will be a SQL file server database. Similarly, enter the name value and increase the cluster size to 2. I'm glossing over every little detail in the interest of time. I have entered the required values of the properties for all the services. You will be able to download the blueprints, and I will post the link at the end of the demo. The 4th and the 5th nodes will be TC server and the web server. First, the TC server. We increase the cluster size to 2 as before, so that 2 TC servers will be deployed at blueprint execution. We drag and drop the TC server service on it, on the node. Now we create a vFabric web server. Enter the name, host name, CPU, and memory again. Drag and drop web server service onto the node. At this point, we will establish dependencies. Dependencies make sure that tasks are performed in the right order. For example, in our use case, web servers are deployed after TC servers, which are deployed after the SQL file servers. Now it's time to deploy the application. This is the name of the application that we created. From the top left, this node is SQL file locator, SQL file server, TCS server, RabbitMQ, and vFabric web server. Click on the deploy button to deploy. Enter the name of the deployment profile, or if you have already created one, select it from the drop-down. Click deploy. Now select the deployment environment that we created earlier. Click on map details. It shows you the logical template and the vCloud template mapping for each of the nodes in the application. Now select the network you want to consume that was created by the cloud admin. We select the defaults, click Next. In the execution plan, we can add tasks that we created earlier. For example, we added VMware EULA task. Just drag and drop the task and drop it in front or after the node deployment. That way, we make sure that it runs during the deployment of the application. Once you have added all the tasks, click Next. Click Deploy. At this point, the app director makes a call to the vCloud director to deploy the application. A vApp will be deployed in vCloud director. In the task summary, you can see the vApp name, and we can verify that in the vCloud director. We open the vApp in vCloud director and verify that it has indeed deployed. Look into VM details. We can see the IP addresses of the VM that were assigned automatically in vCloud director. We can verify that in the vCloud director as well. In the execution plan details, we can see at which stage of the deployment we are in. Looks like the vFabric RabbitMQ is deployed. SQL file locator is deployed correctly. SQL file server is being deployed, and the TC server is waiting on the SQL file to complete, and web server is waiting on the TC server. The vFabric server has completed. This is the instance of the blueprint that was deployed. Finally, let's look at the VM details. Finally, look at the task details. You can get all the information about the start and the end times. At this point, note the IP address of the web server. We are going to log into the browser with that IP address and verify the application is indeed working. The WAR files are being deployed in the TC server. That's why it takes a little longer the first time. This is the home page of the SpringTrader application. Let's log in. Password. And you can look at the portfolio of stocks. We are going to buy some stock today. We enter the symbol of VMware, get quotes. We buy 100 shares of VMware stock, hit the buy button. We wait to refresh the browser, and you can see in the recent transactions that we bought 100 shares of VMware.